So on the bell ringer, we just did a review of factoring. I'm not sure how many of you actually got it because some of you don't like to ask questions. So let's go through some factoring review questions real fast on this focus lesson before we get too far. Again, make sure you ask questions over anything. Now, if some of you did not have me last semester, or you did not learn how to factor from me, which means that if somebody else taught you how to factor and you already know how to factor, then you can pretty much just go ahead and move past this point and go on to the other stuff, because there's no need for you to go through the factoring if you already know exactly how to factor without me. Let me say that again. If you already know how to factor on your own, you do not have to listen to the factor review, because you're going to probably try to blame me for confusing you or something else. So if you already know how to factor, fast forward looking at the work until you get to problem 1, and then you can join from there. But for those who don't know how to factor, or who can't really remember how to factor, you might want to pay attention to this, because you have to be able to factor if the topic of this is factoring to solve quadratic equations. So looking at all this, we have this problem, and what you do, as we learned, is you are looking for numbers that multiply to equal. Again, this was the notation we used, and you kind of have to get used to this. Multiplies to equal whatever the first number times the last number is. Well, this is 1 times negative 14, so it multiplies to make negative 14, and adds to make whatever this middle number is, which is 5. That was the setup that we had on factoring. Multiplies to make negative 14, adds to make 5. What we learned to do is make a tree for this number 14 first, starting from 1, which is 1 times 14, 2 times 7, 3 doesn't go, 4 doesn't go, 5 and 6 doesn't go, and there's my tree. We also learned that if it multiplies to make negative 14, that the signs had to be different. And because of that, one of these has to be negative, one of these has to be positive. We also learned to say if it adds to make a positive 5, that means that my bigger side has to be positive, which means that my small side has to be negative. Then we looked and said which one of these groups makes positive 5, and that is negative 2 and positive 7. That was the hardest part. That's what we spent, I think, 2 days working on before we even did factoring, but that's where you have to be able to get. Once we do that, we take this piece and simply turn into x. So we put x over this number, and we put x over the other number, and as long as these two fractions are reduced, this is x over negative 2, which is fine. This is x over 7, which is fine. Keep in mind we turn that into x minus 2 and x plus 7. Again, if you did not learn it the first time, it's not going to be easy the second time, which is why you're going to have to do some work today. You might have to actually spend most of your day just having me make up some factoring questions for you. I can do that. I've done this for years. But just make sure you get the factoring down, because if you cannot factor, then you're not going to be able to factor to solve a quadratic equation. This one here, you want numbers that multiply to be, again, first times last. 3 times 6 is 18, and adds to make, well, this is a negative 11. And so there you go. Again, we make a tree for 18, which is 1 times 18, 2 times 9, 3 times 6, 4 no, 5 no, 6 is here. The fact that it makes a positive 18 means the signs are the same, and the fact that it makes a negative 11 when you add it means it has to be negative and negative. And so you look here. And again, going back to this, you want them to add to make negative 11. Those are your numbers. And again, what we did from here, once we found the numbers, is we took this with a regular x and we put 3x over the first answer, which is negative 2, and then we put 3x over the second number, which is negative 9. 3 over 2 cannot be reduced, nothing can be divided, so your first parentheses is 3x minus 2. 3 and 9 can both be divided by 3, which makes x over negative 3, because remember, this is 3 turning into a 1. 3 divided by 3, 9 divided by 3, which means your second one is x minus 3. Remember that we can check this quickly by going 3x times x is 3x squared, which makes sense. Negative 2 times negative 3 makes positive 6, which also makes sense. Again, the hardest part for the next couple days is going to be factoring. If you do not know how to factor, that doesn't mean you're going to fail the whole test. It just means you're not going to be able to do well on anything that has to do with factoring. But some of you are on the brink and are close enough that you can actually do this. The third type of factoring we saw was the one where we had like terms, to where you look at 10 and 8, because this isn't the type I'm used to where it has x squared, x, and a number. This has 10 and 8, which can both be divided by 2, so remember we took off a 2. And then this has 2 x's and 1 x, so we took off 1 x. Then we opened up parentheses and did the reverse distributive property, with 10 divided by 2 being 5. I had 2 x's, I took 1 off, I'm left with 1, plus 8 divided by 2 is 4. I had an x, I took it off, and that is it. And what I said about this is you can check it real fast. 2 times 5 is 10 with 2 x's. 2 times 4 is 8 with 1 x. So that is the general idea on how to solve by, or how to factor, at least to get to where you can solve by factoring. So writing this down as I say something real quick, solving by factoring is really easy. Let me say this again, and hopefully you've learned to trust my words. I don't lie to you. Solving by factoring is easy. The problem is factoring is tough. Let me say that again. Solving by factoring easy. Factoring is tough. If you don't know how to factor, you won't be able to do it. But if you can at least kind of work on your factoring and get close, then it's going to be an easy thing to do. So as this thing that you're writing says, when x squared is in an equation, move everything to one side, which means make it 0 equals or something equals 0. After you factor the equation, which again, this is the skill you're going to need, set each equation equal to 0 and solve. So let's look at what solving by factoring actually ends up looking like. You will end up with something. Think about the fact that we just factored these things earlier. It looks kind of like this, equaling 0. Logically, what this means is that some number times some number equals 0. It has to equal 0, otherwise it doesn't work. But let's think about that. If I had a triangle number times a square number equaling to 0, one of these numbers has to be 0. If triangle was 1 times 0, 1 times 0 is 0. If triangle was 5, 5 times 0 is 0. If triangle was 100, 100 times 0 is 0. So that means that this has to be 0, or triangle has to be 0. 0 times 5, 0 times 15. So as long as it's got that set up, when you multiply it equal to 0, what tells you is that one of these things has to be 0, and that's what you write. You say to this person that if this times that equals 0, then 4t plus 1 has to equal 0, or this piece, t minus 2, has to equal 0. Again, think about it. If this equals 0, it doesn't matter what's over here because 0 times whatever that number is works. If this equals 0, it doesn't matter what that is because anything times 0 is 0. And so now you simply solve them. Subtract 1. Again, this is where I said it's easy. 4t is negative 1 divided by 4, and t is negative 1/4. That is one of your answers. Now you go over here and solve as usual. Plus 2 plus 2. T is equal to 2, and that is your answer. This is called solving by factoring, or it's the end result of solving by factoring. Think about it. It wasn't hard to set that equal to 0. It wasn't hard to set that equal to 0. It wasn't hard to solve. The only thing that's going to be tough is getting from where you are to here, and that's just called factoring. So don't be afraid of the end result. Focus on the tough part, which is the factoring today, and make sure you get that part at least closer to where you need to be. Remember, you have a couple of weeks until the test is here, so that's going to be the main thing. Also keep in mind, I'm not going to give you 15 factoring questions on the quiz because I know that that's going to kill a lot of people. What I'm going to do is give you some questions that are just like this to make sure you understand it, and a couple questions that have just factoring. I might give you one that has the whole thing, but most of them are just going to be factor this, it's going to be solve that, which again, you should be able to solve that. You should work on trying to factor this, and I might give you one where you go all the way through that way. Alright? Problem 2 says, what are the solutions? Now here, again, we want to solve this. The difference between today and yesterday, or the days before, is that this has an x squared and an x. What we saw before was just an x squared, where we'd move the number and then get the x squared by itself, but this has an x squared and an x, which is confusing and hard to deal with. That is why we have to factor. And so what we have to do is take this, it's set equal to 0 already, ignore it, and go through our factoring process. Again, this is what you want to work on today. I want numbers that multiply to be 15, because of 1 times 15, and add to be 8. Make your tree for 15, 1 times 15, 2 times, nope, 2 doesn't go, 3 times 5, 4 is it. Again, this means that the signs are the same because it's a positive 15. This means everything has to be positive. And the numbers that make 8 are 3 and 5. So what I'm going to do in my scratch area, because this is still solving, what I'm going to do in my scratch area is finish the factoring. This is going to be a regular x over 3 and a regular x over 5, which gives me the answers of x plus 3 and x plus 5 equals 0. Now notice, once I factored it, it looks just like this easy question we just did, where it says that this value times that value equals 0, which means that either x plus 3 has to equal 0 or x plus 5 has to equal 0. And this is where it gets easy. You simply subtract 3 from both sides. X equals -3 is one of your answers. Subtract 5 from both sides. X equals -5 is your other answer. How do we know this is true? Well, think about it. We can plug that in. Parentheses -3 squared plus 8 parentheses -3 plus 15. Look at your answer. You got 0, so it worked. Go back, turn that -3 into a -5 because that's my second answer. And let's see if we got it right. 0, so it means we did. So again, the hardest part of this problem is all this work that you have to get down to get it factored. Once it's factored, it should be an easy question. Okay? So I'm going to stop with that because there's no need in just killing you with a whole bunch of factoring questions. You know what you need to work on. If you need to work on your factoring, like I said, find some time to come and find me and have me make some things up for you. While you're writing this, that is. So go ahead and write the use factoring when and use algebra when, because this is what we learned yesterday, this is what we're learning today, and the reason you learn them both is because there is a time for each one. And so even though you may not know how to solve by factoring right now, assume that I am going to work you well enough that you're going to eventually know it, and that's what we have to go off of. So you still have to know when to use it, you just may not know how to use it yet, and you'll grow into that. So just be patient. Again, don't let your frustration make it so you don't think and can't learn. Just stay patient with me while you're writing this. Problem number 3 is going to say determine whether to use factoring or algebra on each equation. What I explained to you was we use algebra when there is just an x squared. Okay, so if you look and you see x squared but you don't see anything else that has a variable or any other type of variable, then you can solve using algebra. If you look and you see an x squared and an x, then you have to solve by factoring because that's the only way you can deal with the x squared and the x. And that's really what it comes down to. So looking at this, and we're not going to work these out, we're just going to make the call, and I'm going to show you kind of how to make this choice on each one. So for problem 3, if you saw this, the first thing you do is you recognize it has an x squared, which means this is higher than the level that we were used to before. Kind of like when I said squareds and square roots are in town now, this is higher level. But once I notice that there's an x squared and an x, it means that I have to factor. Now we'll learn a third option that actually solves all of them, but for right now, for what you know, if you see an x squared and an x, you're going to have to factor. Look at B. B, I see an x squared, which means we're in a higher level of math, but I don't see anything else, which means, check it out, I can just do -19, etc. Kind of like we did yesterday. This one I can use algebra. I can move the numbers, divide by 8, remember doing that, and then square root both sides and get plus or minus whatever my answer is, as long as there's just an x squared with no x. If you look at C, I'm actually going to show you kind of how this works also. Here I see an x squared, which means that it's higher level math, but I do not see any x's, and so what that means is that I can use algebra. Watch and remember what we did before. I can move this over here just like I'd move an x before. Those would cancel, and I'd have 4x squared plus 4, and just like I did before, the weaker number goes first. From there you divide by 4 and you continue going on. Again, this would be done by algebra. Because of the fact that you only have an x squared and an x squared, you can combine your x squared using algebra, but you cannot do anything if any one of these two things had an x on it. Alright, and the last question before we get started is 2x squared 8x minus 3 equals 5x squared plus 2x. Again, once I see an x squared, I know it's higher level math. The problem is once I see one of these or one of these, I recognize that it's not going to be as easy as I want it to be. I am going to have to factor this problem or use option 3, which we will learn later. Okay, so again, I try to make sure you use your common sense. I try to make sure you're not just blindly walking in the dark, and this is kind of making sure you're aware that all the things we're learning aren't just random. There are times you can solve by graphing, there are times you can solve using algebra, and what you're learning now is there are times you're going to have to solve by factoring, or again with the third option we're going to learn later. There is another option, we'll get to it, but it's not going to be fun for some of you because it's just something that a lot of people don't like. Anyway, Get the worksheet from me if I haven't given it to you already. Again, make sure you are working on learning. I need you to pass. I always give a lot of easy grades or give a lot of passing grades for the first semester because it is the first semester, but I do not give grades in the second semester. So you're going to have to earn this. You're going to have to work. I'm here to help. I'm letting you work together. I'm giving you as much practice time as you need. Just make sure you use it. And again, I believe you can do it, so let's knock this out. Other than that, like I said, go ahead and get the worksheet, and good luck working today. It's a short day.